Good morning and welcome to our latest webinar on indoor air quality. I'm really pleased that you've been able to join us today because I think it's a very sort of important topic right now. And I think it's interesting. Over this last year, or certainly yes, I suppose 2020, we very much focused on health. And with the recent pandemic, we've actually looked at some areas of our health and neglected others. Now, many people working from home have suffered with musculoskeletal and mental health problems. And because of this, perhaps we have focused on those, but now we're looking more at our wellness and how we need to look after ourselves and function well. I think air quality has been overlooked a lot in the past, as has air hygiene. I mean, in various times in my past, I've been asked to look at areas where people said they've been concerned about the lighting. And when I've got there, actually, it's not been the lighting at all. It's been the other environmental factors like air quality. So I think it's really exciting we're looking at this now. So I'm delighted that Mike Booth has been able to come to talk to us today. He's an ambassador for indoor air quality, particularly in shared air environments. He's helped numerous clients to solve their indoor air quality challenges and has a great understanding of the clean air technology. So I'll be really pleased for him to give his presentation today. Just a few housekeepings before I hand over to him. If you've got any questions, please put them in the question box and I'll put as many as I can to Mike at the end of his presentation. The other thing to say is we are recording this presentation, and so if you have any technical problems, don't worry, you can always come back and listen to it later. So I think that's enough from me, enough hot air actually from me, Mike. So can I over to you, please?
Perfect. Thank you so much, Catherine, and welcome to everyone who's been able to join us today. We really appreciate your time, and hopefully you get as much value out of this as possible. So we're going to dive straight in, and as Catherine said, you know, the last few months have really put a magnifying glass over this topic for us as an organisation. This is something that we've been believing in and really flying the flag for better indoor air quality for almost a decade now. But I think it's fair to say that the last few months have really changed people's awareness and people's understanding of just the sheer importance of indoor air hygiene. So we're certainly going to dive into this topic in a lot more detail today. We are going to acknowledge the impact that COVID-19 has had on this situation, but we're also going to cover off some of the other things that can make indoor air quality go bad. So in terms of the topics that we're going to work through, first of all, we're going to acknowledge the impact of COVID-19 and really look at why this is being seen as an airborne threat. And this is something that's really evolved over the last few months as the guidance has come out and as the scientists and as the experts have really explored this. Our understanding of how this is transmitted has just increased and increased and increased. And really is pointed more towards airborne as a transmission method than was originally understood back in February, March time of this year. Of course, this has an impact on many of our environments at home, at work, at school, in our healthcare facilities, but we are going to take a look in a little bit more detail on the impact this has on the working environment and why this is a particular challenge there and what other things can be done to solve for this issue as well. And then finally, we're going to talk a little bit about what does a suitable commercial solution look like. Just before we wrap up at the end. As Catherine said, there will be an opportunity for questions. Feel free to write those down as we go through, enter those into the system, and we'll try and get through as many of those as we can. So one thing I want to touch on really quickly is just our background on this particular product category. So like I said, we've been in this area of air purification, air hygiene for almost a decade as a company, as fellows, as a global business. And we really divide this into two main zones. We do have consumer solutions, primarily used in residential applications. It's for personal use. Typically pre-COVID, the driver was really allergy, asthma, people who are more health conscious or people who are living in maybe more polluted city environments. So we do play in that territory, but what we're here to talk about today is really our commercial solutions, really for business use, but across many different vertical types as well. Facilities where we work, where we learn, where we play, or where we're there to recover or get healthy again. So we are going to double tap into commercial solutions, absolutely. But one thing that we have to acknowledge in the marketplace today is there are residential solutions that have been sold into commercial applications. I think it's important to understand that we have both, but we really believe in the right solution for the right application. So the airborne threat, really there are three main sources of information that we can look upon in order for us to really understand the threat of airborne transmission when it comes to COVID-19. First of all, there's the global health authorities, organizations such as the WHO, the World Health Organization. There's the CDC in the United States, and then there's also the European arm of that, the European CDC, which is the Center for Disease Control and Prevention. All of these are incredibly influential voices and opinion leaders, and are really influenced by a number of experts and scientists as well. So it's a real critical source of information. Secondly, as we go around this wheel, there is a significant amount of re-entry guidance that's been published. The areas that we typically look to are more air related. So organizations such as ASHRAE or REVA, these are really a US and a European association focused on all things air, HVAC, ventilation. And then in the UK specifically, CIBSE, which is a great source of information as well, which I'll go into in a bit more detail. And then finally, just the sheer amount of data and research. There is a lot of academic studies, scientific studies, peer-reviewed articles that have been released early just because of the sensitivity and the heightened awareness, all of which has really just increased our understanding of how this particular virus can be transmitted whilst continuing to build on our knowledge of virus transmission in general. So what we're going to do is go into a little bit more detail on some of these different topics. So first of all, let's start at the basics in terms of the understood transmission methods. There are really two primary zones of our understanding and of our thinking. First of all, by contact, which is really touch transfer, person to person, or person to surface, surface to person. And then from an airborne perspective, this is really divided into two main zones. The first one via large droplets, which become airborne as we cough, sneeze, or talk. They're typically larger in size, above 10 microns, in some cases above 50 microns, so they start to become visible to the human eye. And that's really linked to the social distancing principle of 1 to 2 meters. Because of their size and their weight, they're going to go to the ground or to a surface pretty quickly. They can still be picked up by an individual, so that surface transmission is still a factor, which is why hand hygiene and surface hygiene continues to be absolutely mission critical. But the other zone of airborne transmission that's becoming more and more understood and more accepted is the fine particle or the small particle transmission. Particles that are below 5 microns in size, completely invisible to the human eye, and because of their size and because of their mass, they're going to remain airborne for a much longer period of time. And this is where some of the studies and some of the clinical evidence will come out and really continue to support this. They're still ultimately generated via us coughing, sneezing, talking, singing, shouting, all those things that we can do, but they can remain airborne for some time. And then the final transmission method, which is expressed in the visual there, is the fecal-oral route, of which there's more and more concern around, which by simply flushing a toilet can, because of bodily fluids getting into there, can release it into the air, and it's another way of people interacting with the virus, either from a respiratory point of view or becoming surface bound and then touched thereafter. So just a ton of building knowledge really as it relates to this. But as we look at the health authorities around the world, all of what you see on the screen here is typically well understood and well represented across the globe. So looking specifically at that second zone of the wheel that we looked at earlier, the re-entry guidance. So for the purpose of the audience we have today, primarily a UK-based audience, we're going to touch on CIBSE. So CIBSE is one of the leading voices in the UK when it comes to building engineers and really all things air related. So it's the Chartered Institute of Building Services Engineers. And they published a document back in May all around ventilation guidance. and they've continued to update their guidance as well to their community. Now, their guidance really, there's quite a detailed document that they publish, but I've tried to summarize this in just a handful of bullet points for in the interest of speed. So the first thing is there's really a big warning against recirculation, especially circulation that is moving air from a space to another space. Our building air systems can often take air from a room, try and retain as much energy from that, mix it with outside air, and then introduce it back into other spaces. If it's moving from one space to another, it's heavily recommended against. It should be avoided anyway, even pre-COVID, but especially in this current situation, it should be avoided. The more recent guidance has said if it's been reintroduced into the same space, it's less of a concern. But our concern would be, unless that's being passed through good quality filtration, that there's still a risk of that increasing transmission. The second recommendation is really to increase the ventilation rates. This is ultimately with the goal of diluting, mixing more outdoor air. I always refuse to say fresh air, because just because the air is being brought from outside, it doesn't mean that it's fresh or clean air, but it is outdoor air. So it can reduce a problem that is being generated from within a building. So the guidance here is to have the system running 24/7, have the system running over the weekend, ultimately with the goal of diluting any potential problems within the space. One of the warnings within this guidance is to avoid just assuming you can throw in a much better filter into the system, because there are some severe limitations to doing so. A better filter within a building system will increase the resistance. Often the specifications of the system were not designed to cope with stronger filtration. So often you can end up doing more damage or reducing the airflow by introducing a higher quality or higher grade of a filter. So it's not just a quick fix that buildings can turn to. Now, within the guidance, they also talk about other air cleaning technologies. One of the one that they touch on is UVC, but it does warn against just assuming that, again, you can throw this into a system and it's going to solve the problem. There are a number of challenges when it comes to disinfection methods or sterilization methods. You need a real fine balance of the right power of those systems, the right exposure to the actual problem, because it needs a direct view of whatever it's trying to sterilize or kill, and the airflow has to be tightly controlled in order for it to be effective as well. So again, it's not a quick fix turnkey solution that organizations can just simply turn to. Now, within this guidance, they also touch on the topic of air cleaners, and what they actually call out here is for an air cleaner or a portable air cleaner to be effective, they should at least have HEPA filter efficiency and have a substantial part of the room air pass through them. And we'll touch on some of these topics when we come to talk about our solution in particular. But I thought it would be useful to walk through some of this guidance. And then finally, in terms of some of the data and the research that's out there, the best example really that we can show of this, many of you may have seen this on the news as well, was back in early July, when a group of 239 scientists all grouped together to write an open letter to the World Health Organization. The title of the letter being, "It's time to address airborne transmission of COVID-19, which is a pretty direct title, I'm sure we'll all agree. And within this, the quote that we've pulled out is that multiple studies have demonstrated beyond any reasonable doubt that viruses are released during exhalation, talking, and coughing in microdroplets small enough to remain aloft in the air, posing a risk of exposure beyond the 1 to 2 meters guidelines that are out there. So again, just underlining the idea that this is well understood and accepted as an airborne issue today. So moving into the office environment, one thing that we like to touch on is this very well respected hierarchy of controls methodology, which is not specific to COVID in any way, shape or form. This can be applied to many, many different types of hazard avoidance or hazard prevention. And it goes from at the widest point, what's the most effective control measures that we can put in place, all the way down to the bottom of the triangle, which are the least effective controls and measures that we can put in place. So as it relates to COVID, we can walk through these in a bit more detail one by one. So from an elimination standpoint, really the thing that we can do here is what we did in the early stages, which was full lockdown, full closures, stay-at-home guidance and the government controls that were really put in place. From a substitution standpoint, one example of this would be to avoid asbestos exposure, we moved to alternative building materials. But in the world of COVID, there's really not much we can do from a substitution standpoint. Moving down engineering controls, this is really right in the center of the level of effectiveness. Ventilation measures, filtration measures, physical barriers, things that enable us to control social distancing, something as simple as removing tables from an office layout or from a restaurant, for example. Moving further down, administrative controls, so de-densifying the office space, work from home schedules, signage, cleaning protocols, and then finally PPE. What's actually interesting when you look at this is that a lot of the focus has been on what actually, when we look at this methodology, is seen as the least effective thing because it's highly dependent on every individual contributing to it. That's not to say that PPE isn't important, it's absolutely part of the puzzle, but where we sit as a solution and really where there's a lot of respect for a more realistic, ongoing, sustainable control is in this level of engineering controls. Now, one example, and there's been many of these from around the globe that the scientists and the experts have really leaned on, and what this one was actually highlighted within a number of different studies. This is an example of a what's called a super spreader event. This was in an office environment in a call center in South Korea. This was one floor of a building, the 11th floor of a building, where one known infected employee came into the workplace. There were 216 employees on this floor, and 43 to 44% of them became infected. All of the blue chairs that you see highlighted on the visual became infected, and they would attribute this to that one infected individual coming into the environment. Now, it's very unlikely that that's happened just through being within a 1 to 2 meter distance of that individual. This is one of the studies that have been used as an example of the belief of the airborne transmission risks. And there's multiple examples and multiple data points that are very comparable to what we're seeing on the screen here. And one important point from us, this is really critical. Like I said at the start, we've been in this product category now for almost a decade. And whilst we're talking a lot about viruses right now, for us, when it comes to indoor air quality, this problem by no means stops at the topic of viruses alone. Typically, we spend around 90% of our lives indoors, typically spending 9 hours a day sharing that indoor air with other people in many different types of facilities. Now, there's many sources of this, but one of the leading ones on a global level is the EPA, the Environmental Protection Agency, and they actually came out and said that indoor air is believed to be 2 to 5 times more polluted or dirtier than outdoor air. This is ultimately because of the way that we build our buildings today. We want our buildings to be energy efficient. We're really focused on the operational efficiencies and the running costs. And we've really taken our eye off of the importance of occupant health when it comes to the built environment. We need to make our buildings breathe for us now via mechanical means, and we can no longer depend on simple things like natural airflow moving from under doorways and through windows and single glazing and all those things that helped a building breathe a few decades ago, which has all led to this term that we're all very familiar with, which is the concept of sick building syndrome. In terms of the specifics of things that can make indoor air go bad, right now, the first one, bacteria and viruses, obviously a major focus right now, but it's not just COVID-19. The seasonal influenza affects the UK year on year, and just the common cold. These things, we all know the feeling of going into work when you're feeling not quite on at the top of your game, and the impact that has on others within the workplace, I think, will be much better understood post-COVID. Allergens and asthma triggers, a significant percentage of Europeans and Brits alone reportedly suffer from some form of an allergy, many of which are linked to respiratory conditions. And common things within the everyday environment, such as an office, can really affect people's quality of life if they are asthma sufferers. Pollution can be outdoor air making its way inside a building, but also indoor generated pollution, things like volatile organic compounds, These can be things as simple as printer fumes, cleaning chemicals, things that are coming from our flooring, our paints, our furniture, our carpets, whatever the case may be. And there's tens of thousands of these things being emitted into our air on a daily basis. And then even, finally, something as simple as odors that just have an impact on the way that we can enjoy an environment, and really a common cause of complaint when it comes to air quality within many different types of commercial buildings. So what are the benefits in investing in a solution such as this? They don't just stop at avoiding virus transmission. Obviously, that's where the major focus is today, but there's far more benefits when it comes to investing in indoor air quality. There's multiple studies that back up the idea of improved productivity. One particular study from the World Green Building Council highlighted productivity gains of between 8 to 11% based on their investigations of businesses who have specifically invested in their indoor air quality. There's data points around absenteeism reduction, presenteeism reduction, improving the overall perception of a facility, being able to present what you're doing for the benefit of occupant health, reducing complaints, and then in general just creating an environment that embraces occupant health. And this is such an important part of company culture nowadays for many businesses, and this is just one of many ways to really demonstrate what you're doing for the benefit of your occupants, whatever type of facility it is that you're operating. So the final part that we wanted to get to before we do open it up to any questions is really understanding what does a commercial solution look like. So this is where we're going to talk in a little bit more detail about Aeromax Professional. And really for us, we divide our point of difference into four main zones. First of all, we talk about our solution being smart. I go into a little bit more detail about this, but ultimately this is the way that we use sensors so that our solution is doing the thinking for you, and you really don't have to understand what way you want your machine to be working that day. It's all about simplicity and automation. Secondly, an air purifier needs to be effective, and this really comes down to the filtration that you use in order to deliver on your promises. Third thing is integration. Our solutions are really designed to be mounted on the wall, to be part of the facility, to really put the facilities or the ops team in full control of the benefit that they're delivering. And then from a commercial solution, you really expect reliability. And for us, what this means is a good build of a unit and high warranty periods as well. So most of our solutions come with a 5-year warranty when it comes to our commercial range of air purifiers. So going into a little bit more detail on smart, there's really two main ways that we deliver on this promise. First of all is our EnviroSmart technology, patented technology. This is the combination of sound, motion, odor, and particle sensors built into the unit that ultimately enable the system to monitor occupancy and air quality. Now, in today's climate, imagine a solution that not only responds when the air gets bad, but also starts to work harder the minute it detects increased occupancy. For a meeting room environment, for a kitchenette area within a building, for an entranceway in a building, as footfall increases, as density increases, our system will automatically begin to work harder because it is assuming problems can start to occur as the amount of people increases within a space. This enables the machine to operate in two primary modes. One mode that really respects potential noise concerns that will only go into the higher fan speeds, the noisier fan speeds when the space is unoccupied. But typically, especially in today's world, we're finding that automatic mode is the most common one. But the ultimate benefit here is technology that's responsive, energy efficient, because it will also power down if it's not needed to be working at that moment, and helps extend the filter life as well. Now, our real hero piece of innovation when it comes to smart is our Pureview technology. And what this is a screen right on the front of a number of our units that is there to really reinforce exactly what the machine is doing at that point in time. There's two primary modes that can be selected. The first one is really a status of how the air in that room is right now, either shown as clean or as cleaning, to show that the machine is proactively dealing with an issue. Or reactively dealing with a detected problem in the air. And we also show the actual percentage of particles being captured in real time. And we can do this because we include two laser sensors within the unit. The second screen mode is a more data-driven mode, which is literally showing the PM 2.5 level, or a particle, an indication of particle levels of the air as it enters the machine and also as it exits the machine. So we're showing our performance in real time right on the front of the unit. And then finally, the benefit of being able to show filter information and filter change warnings right on the front of the unit as well. So ultimately, the benefit being that this data is there for the facility manager to see at a glance. How is this performing? But also real maximum peace of mind for the facility occupant. And you can only imagine today the message that this enables a facility to deliver to their occupants right now. So from an effective standpoint, like I said, this really comes down to the filtration that's being used within the system. So we use 4 main stages within our filtration process. First of all, a pre-filter, which is just really there to protect all the filters in the process. Then carbon filtration, which is really there to deal with odors and VOCs. But the real workhorse in today's world is our true HEPA filter. And what this enables us to do is say 99.97% capture efficiency at the size of 0.3 microns. Now, one point that's really important to clarify is that HEPA filters don't work like a sieve or like a net. They don't stop working at 0.3 microns. And actually, there's a lot of data out there that suggests HEPA filters actually increase in their filtration efficiency at some even smaller particle sizes because of the laws of physics and because of the way that filtration actually works. And we actually have an antimicrobial coating on the filter as well, which means we can demonstrate through our own testing that that bacteria and fungi won't grow and develop on the filter itself. And then finally, we include a bipolar ionizer within the system, which is really there to increase the filtration efficiency as the air is continued to be filtered within the space. Now, we've already touched on this briefly, but one virus that we're very familiar with that comes into our cultures on an annual basis is the flu. And what's actually well understood now is that the air is a very common, or even in some cases, the most likely transmission method of a virus such as influenza. And this is ultimately because of the distances that a virus like this can travel. So what we did is a few years ago, we worked with a independent lab in Europe to test our machines specifically against airborne influenza. We used H1N1 for the purpose of this. And through this testing, we was able to demonstrate that our system can reduce airborne levels of H1N1 to a level of 99.99%. Within a period of 35 minutes of operation. Now, what's important to know is that we set this up to reflect real world conditions. So we didn't introduce the virus in front of the system and just detect what was coming out of the back. We set this system up to deliver 5 air changes per hour, which is also our recommendation when we're introducing a system into a real world environment, and really tested its performance in those mimicked real world conditions, albeit under laboratory conditions at the same time. One thing that you'll remember from that SIPC guidance that I mentioned a few slides ago now was the importance of good numbers of air changes as you consider a portable solution as they've recommended. And it's really critical as you look to a commercial solution to understand airflow and ACH, or air changes per hour. Ultimately, these are major indicators of the power of a system. And our belief is that these need to be coupled with smart technology, responsive technology, and also the benefit of wall mounting a solution, which not only puts the control in the facilities team, but it also actually enhances the performance of a system as well. Now, I promise I won't get too scientific with this, but I did want to just show one example of some simulation that we built, just really to understand and to be able to present the effectiveness of a solution such as ours. So for this, we used a very common shared space within any facility type, which is a communal bathroom or a communal toilet within many different facility types. So the first scenario that we're looking at right now is all toilets flushing continuously at the same time. The red is bad and blue is good. And what you can see from this simulation is there's quite a lot of red and not so much blue air as we monitor the concentration of airborne contamination. If we freeze the red and really show the concentration of the bad air, you can see the spread, it moving into the breathing zone, and just how people within the space are going to be interacting with that as they spend time in the environment. Fast forward to the second scenario down the bottom. Here we're showing an air quality system in place, reflecting the performance characteristics of our solution. You can instantly see a lot less red, a lot more movement to blue, and a greater coverage of the blue within the space as well. We're able to really dilute the problem, decrease the concentration of the bad air. And if we freeze this, you can see that the issue is far more controlled at the source of the problem. Now, we can't remove the source because we need toilets in our facilities. There's no question about that. But what we can do in this instance is we can significantly reduce the exposure to the problem that can become airborne. In real time, we were able to reduce the concentration by 64%, bearing in mind that it's been constantly introduced as we do this testing. So that's a very good performance. Now, what we did to really understand how else you could approach this is we investigated what would you have to do to the HVAC system to achieve this same level of benefit. You would actually have to increase the airflow rate of the HVAC system by 250% to increase this same level of performance as what Aeromax was able to deliver in this particular simulation. So just wrapping up now, and I'll hand over to Catherine in a second just to check if we have any questions from the group. But I did want to just take a minute to introduce the range that we have. We have 3 models in the range, really the primary difference being the level of or the room size that they're designed to cater for. And the room sizes I've included on here are a combination of the 5 air changes per hour performance and then the 3 air changes per hour performance. Typically, we recommend 5 in today's world. The guidance out there is recommending a minimum of 2, especially if it's complementary to your increased dilution approach. But we believe really a minimum of 3 should be aimed for. All of our solutions are designed to be wall mounted, but we also have a stand option available. And our smallest unit is actually recessible into the wall as well. All of the sensor technology that I mentioned is featured on all the units, and it's the 2 on the right that feature the Pureview screen that I talked about a short while ago. So final slide from me, just to really wrap up what we've been talking about today. Ultimately, our belief is that air deserves a place as part of an overall hygiene strategy. Hand hygiene is critically important. Surface sanitization does not go away, but air for us is part of a 3-pronged approach of hand, surface, and air. Ultimately, the benefits as we look to reoccupy our facilities and get people back into our buildings, it's moving away from reacting to these situations and putting a proactive solution in place. For us, something that's smart, effective, integrated, and reliable is key. And really increasing the level of focus on the health of the occupants. Really positioning air as part of the overall hygiene strategy and not seeing this as a quick fix temporary measure, but fully embracing the concept of air hygiene as we look to future-proof our facilities, not only for virus risks of the future, but in general to realize some of the benefits that we touched on a little earlier in today's webinar. So with all that being said, we covered a lot. Hopefully there was some value for our audience today. What I'll do now is pass over to Catherine and check in if there's any questions from the audience.
Thank you, Mike. That was very informative. Yes, we do have quite a lot of questions. Some of them I think you may have answered as you've gone along. But first of all, can I say, I mean, I'm quite positive. I can see, I think, beyond COVID a wee bit. What do you think the legacy really is for the future of air quality and those things?
Yeah, great question. So obviously, no doubt today that the world is significantly focused on the issue of virus transmission, but I think what this has done and what this will continue to do is really just amplify our understanding of indoor air hygiene in general. If you look at things like the well building standard and other comparable certifications such as those, they include and are very vocal about the importance of air hygiene as part of an overall approach to occupant health. So it's been well understood. I just think it's been a topic that's been relatively easy to ignore or more of a nice to have. We honestly believe that this will leave a lasting impression, and as we move hopefully closer to a vaccine, which we're all hoping for. And really to get control of this issue on a global level. I think the focus will switch to other issues of indoor air quality, like we touched on earlier, allergy and asthma concerns, in general, just other things that can make us sick within a building, germs and viruses and bacteria related, odor, like I touched on as well, and just a greater understanding of the impact of pollution, especially in city environments as well.
Yeah, I agree. Um, I've got a question here. Low-cost air quality sensors can have significant problems with accuracy, long-term drift, etc. How do you deal with these challenges?
Yep,
That's
great
a technical
questions.
one there, I think.
Great question. Great question. So yeah, I asked that exact same question to our engineers. So one thing, one of our advantages is really this is a ideated, engineered, developed, manufactured solution from fellows end to end. So I'm lucky I can pick up the phone to the team who did everything from the industrial design, from the filter layout, from the air path logic, everything. So I challenged the team on this as part of the development, especially when we introduced the Pureview screen as well. So first of all, we decided to go for a much more expensive sensor within the system. Now, obviously, you can spend thousands of pounds on air quality sensors if you're really focused on annual calibration sensor approach. But you can also spend less than $1 on a sensor in a unit as well, and we by no means would go down to that sort of a level. So we have self-calibrating sensors in our system. There's a level of self-maintenance within those as well, and they're tested to understand that drift, and they're calibrated to embrace that drift as well over their lifetime period. Obviously, we have a 5-year warranty in our solution, so we want to make sure that anything that we put into the system is reflective of that warranty period as well, as a bare minimum.
Okay. I mean, that probably fits in actually with the next question, was asking how often the filters need to be changed.
So the typical interaction with the system, it would be an annual filter change. We've got a couple of different options with the filter sets. The standard out of the box filter set is a HEPA and a carbon, 2 separate filters. And the HEPA filter is an annual filter change. The carbon is every 6 to 12 months as well. The simple approach that we've also got is a hybrid filter, which is an all-in carbon HEPA filter, and that's just a once per year filter change. So relatively low maintenance.
Okay. We've had a few questions. I'm going to try and sort of wrap them together, talking about the safety of air conditioning, the use of filtration, and then having a recirculatory system, and about an air conditioning system that cleans the air 12 times in an hour. I think you really covered this in your presentation, but maybe it's just worth going over, the problems with recirculation and the need for outside air.
Yeah. I mean, this is a common discussion point, and in all honesty, anyone who's asked a question on this today is probably using a different system or slightly slight variations within their system. But I guess a couple of headline comments that might help. First of all, a typical air conditioning approach might be a split system, which is not pulling in any air from outdoors. It's just using some sort of kind of refrigeration or coolant approach or heating approach to treat the air within the space. They typically use zero filtration. Any filter that's in there is there to protect the machine, not to protect the people. It won't be delivering any sort of real significant particle reduction benefit. And those are the systems that are being warned against. There was one restaurant study in China in the early stages of this virus outbreak that was able to show because of a split system air conditioning approach within a restaurant, one infected person came in, and I think 7 or 8 people within an hour and a half dinner, they ended up becoming infected in the coming days thereafter. So those split systems definitely recommended against. The logic has changed slightly in the last few months. So if there's recirculation where air is being reintroduced into the same environment, if it's been treated with a level of filtration, then that's been accepted. But there's also some warnings against using too much of the same air as it's passed back into an environment, just because of the risks of increased air movement without high levels of filtration can actually increase the problem. And typically a filtration system within an HVAC integrated system is just not going to get to the level of filtration of a HEPA filter, or most of them aren't even using a high grade filter within the system. So that'll be a few comments on that topic. But I'm also more than happy if there are any further questions on this topic in particular, then people can make contact afterwards, connect with me on LinkedIn. I'd be more than happy to talk about specific needs in specific facilities.
Yeah, I think actually probably, Mike, due to the time, I've had a few people tell us that they've had to sort of log off. So I think if you don't mind answering some of the questions online afterwards, I think that might be quite helpful.
More
We'll
than
get those
happy.
sent to you. Just one last one. One lady asked a specific question. They're saying they're using the REVA guidance. Is that okay?
Yeah, I mean the REVA guidance as well. So I think the SIBSI guidance is UK specific. The REVA guidance is the kind of European view on all things HVAC related. It's very consistent with the ASHRAE guidance, which is the US body as well. Yeah, I mean that is good guidance as well. It's pretty consistent with what I talked about from SIBSI. Within that REVA guidance, it also highlights the benefits of considering a portable air filtration system as well. So yeah, we use, depending on what market we're talking to, we use all that guidance to just highlight what should be done. The real thing to bear in mind is some of those points that I touched on earlier, which is the guidance is to kind of increase the flow rate of the system, but that has pretty significant running costs and sustainability concerns with it as well. So it might be fine for a short-term period, but how long term is that, and how sustainable is that? And the other thing as well is really considering, when it comes to increasing the filtration efficiency in a system, just be mindful of the limitations of the system you're using today, because like I said, just all of a sudden sticking in a better grade of a filter in a building system, it's just not that simple because of the increased resistance and the airflow impacts. You can actually end up worsening the air that you're delivering rather than benefiting the occupant at the end.
Excellent. Well, thank you very much, Mike, and no doubt these conversations will continue. So just moving on, just to sort of close, just to say that we in March Posturite were launching our assessor community, our DSE assessor community, and as many of you know, that was being put on hold. However, we are reinvigorating that, and we're now planning to run this event as a virtual event in October. So if you'd like to register for our community, please come to our website and you can do so. But we'll also put a link in our follow-up email. So any of you are interested in all things DSE and DSE assessment, I hope to see you then. So really, once again, thank you, Mike, for your input today. And I hope that everyone has a great bank holiday weekend. And I look forward to seeing you all on another event soon. Thank you very much. Goodbye.
Thanks, everyone.